let us discuss about the refraction at convex surface. Here the object is placed in rarer medium and the real image is formed in the denser medium. Let us consider this as the convex lens. It is a convex surface. Let us consider a convex surface with a rarer medium and a denser medium. Rarer medium on the left side, denser on the right side. So before attempting to draw this diagram, you should know the steps. The first and the foremost thing is you have to first of all draw the principal axis. So draw a straight line first. First draw a straight line. Next, you have to draw the convex surface and make sure that the center of this curved surface that crosses the horizontal line, that is the principal axis. So this is called pole. So we have drawn the horizontal line, that is the principal axis. One is principal axis. And then two, that is the convex surface, convex refracting surface. Three, you have to identify the pole, which is nothing but the center of this refracting curved surface. Is it clear? Right. Next, you need to identify the media, and this is the rarer medium. So that can be, its refractive index can be represented as mu1. And similarly, 5, that is denser medium, this refractive index can be represented as mu2. And then let us go to the next one. You need to identify the object here. Here the assumption is the object is a point object. Understand? So this is the object, number 6, object, right? Okay, so this is the object. And let us proceed with the 7th one. From the object you have to draw a incident light. So the incident light, it goes like this. This is the incident light, incident ray. It is oblique and it is going like this. Now you have to draw a normal to that point of, that is incidence. This is the point of incidence where you can draw a perpendicular hypothetical line. So this is the perpendicular line. Okay. And now the angle between the incident ray and the what? The perpendicular line, that is nothing but the normal. So what is 7? 7 is normal. And we are able to get the angle of incidence, that is 8. It is represented by I here. Then now once it is hitting, it hits the point on the refracting curved surface. After that it gets refracted. So it is from rarer to denser medium. Therefore it should bend towards the normal like this. So this is the refracted ray. So what is 9? 9 is a refracted ray. Do you understand? Right. And now, as I already mentioned, the normal is very, very important. And here you can find the what? Refraction, that is R. Okay, angle of refraction R. So what is angle of refraction? The angle of refraction is the angle subtended by the refracted ray to the normal. So this is the refracted ray and this is the normal. So the angle between these is R, which is number 10. Now let us proceed with 11. See, the angle subtended by the incident ray to the principal axis is alpha, that is number 11. And what is beta? Beta is the angle subtended by the refracted ray to the principal axis, that is beta. So point number 12. Do you understand? Right. Then let us go ahead with the next one. That is, you have got the normal, So this normal that subtends an angle alpha gamma with the principal axis, that is point number 13. Right? Okay. Now we have identified this object as a point object on the left side on the rarer medium. So the distance between the object and the that is pole is called U, that is the object distance, point number 14. Then there is a distance between the pole and the image. It's called image distance, and that is represented by V, number 15. Got it? And finally, you should note down exactly the radius of curvature, that is represented by R, point number 16. Are you able to follow? Right. So now what you are supposed to do is you have to write down what are these numbers identifying. Okay, so can you identify this number? You please write down the list of all these numbers along with the appropriate label. Can you proceed? Try.